So I'm Brett Cunningham. I did work in incident response, now do cyber intelligence. And I was introduced to memory analysis about a year ago or so, a little bit over. And at first I had absolutely no idea what I was doing. Some of these guys in here I've worked with, and they can tell you it was pretty pitiful. I was given a memory dump during one incident and was told to run strings against it. Ran strings. It was compressed by HB Gary, their memory dump tool, and got nothing back and was just scratching my head trying to figure out, what was going on. Come to find out, I was just doing it all wrong. So since then, I've really dedicated a lot of time to trying to understand what to do with memory analysis and how it helps during incident response. It's really interesting the kind of things that you can get out of a memory dump that you either can't get from a full disk image, or that a full disk image, depending upon what part of the world the compromised box is in, you might not get that image for weeks or months. So the main tool that I like to use is called volatility, and what it does is goes through the memory dump looking for specific data structures that are of interest. And we're going to go through, take a look at some of the data structures and map it back to the incident response process, and you'll see why that's important. So just to start off on what a data structure is, it's like a grouping of variables that just kind of make up one set of data. All right, so in the example that I've got here, the data structure would be called movies. Inside there, you've got your string, which is the title and actor. Those are two different variables that belong to the data structure of movies. You've got the integer, that is the year the movie came out, and the price, which is just a float. To declare a data structure, down at the bottom you see where it says movies Star Wars or movies Van Wilder. That's how you initiate a data structure. So one data structure specifically would be, if you took Encino Man, that would be the title of the movie, the actor, Pauly Shore, year and price you've got there. So how that actually pertains to incident response is that instead of going through and using strings like I was initially told, All right, this would be using strings against the memory dump to look for commands that an attacker has typed in. Here we see, in a very unstructured manner, something of interest. Net time. I know I just did it against the local host here, but that would be something an attacker would do inside of your network. Going through here with just strings, we would end up having to create a dictionary of all those net use commands, net time, ping, telnet, whatever an attacker could possibly do on your network. You would have to build up just a small file of that and have to grep against the strings output of this. Instead of doing that, we get the pleasure of working with volatility that goes through and looks for data structures. One example would be what's called the ConScan plugin. So just to use volatility, it's just a couple Python scripts, a little bit more than that, but that you invoke, and then you pass it the plugin that you want to scan against the memory dump. So we'll go with this is the massive amount of plugins that are available right now, and we're taking a look right now at the ConScan plugin. Here you see all the connections that are residing in memory. And the process ID that it belongs to. Earlier, I just talked about the net time command. We can go through and use command scan. This one goes and looks at any data structure that has, okay, so anytime that you type something on the Windows command prompt, that information is thrown into a data structure. And as long as, not enough time has passed or that memory hasn't been overwritten, you should get it in the command or in the memory dump. So command scan will tell us, like right here, we see the attacker used telnet, used FTP, and then the attacker, which would really just be me, obviously, dumped the memory to be able to analyze it. But going through with strings, we would have had to go and already had pre-populated, a Word file, and look at, try and key off of any telnet, FTP, net commands, and that's just absolutely miserable. Actually looking at what a real data structure looks like. This console information here is what the consoles plugin looks for. Consoles is very close to command scan, and we'll take a look at that. But here you can see a little bit better. All right, here you can see where the title of the window is, the command history size. You see all of those variables that relate to the console information. All right, so consoles here is a little bit more interesting than command scan, purely in the fact that it gives you the results back that you entered in the command, and it will show you that data that has come back. So when I ran that net time command earlier, you see that I messed up. All right, and you see the results that came back from the command prompt. Right here, when I did a directory listing, you see everything that's in that directory. So consoles really helps provide a lot more context in that situation of what the attacker would have seen. One other interesting plugin is called Timeliner. Timeliner here will go through and look for all of these timestamps of different data structures. So like if you want to do like a process listing, that goes through and looks for the eProcess data structure, and in there the process timestamp of when the process was created, Timeliner will go in and extract it. And thread timestamps, that will also go in to any threads and pull out those timestamps. You see here we've also got the registry key last write times. So if any malware tries to change a registry key, it will, the timeliner will report that back. So right here we've got a pretty simple format. It gives you the timestamp that it was able to extract it from. Right here is the actual data structure that it's looking for. So here we've got process. A little bit further down we've got socket. And one cool one is the Windows event log. You know, that Windows event log, you know, really only lasts in memory for not very long at all. But it's really interesting to still have that. And then, depending upon, you know, what data structure is being extracted out, here you've got the process and PID information. Windows event log, you actually had what it was going to write to the Windows event log. So one really interesting plugin is called Malfind. Has anyone here worked with Malfind? I think it was in the Malware Analyst cookbook. And what it does is it goes through and looks for pages in memory that are of interest. And we'll go through and define why that's of interest. But I'm going to use Volatility's vol shell. And that's a lot like WinDebug. So we can go through and do a process listing. With PS, it'll just go through and list all the processes that were active during the memory dump. All right. If we want to change the context to a certain process and actually start looking at the characteristics that make up that process, we just enter in CC. Then we're doing 1096, right? Yeah, I actually changed that up. All right, so we changed the process to the process ID of 1076. And we can start taking a look at the interesting data that pertains to that process. So we'll go ahead and just take a look at what the eProcess data structure looks like. And at any time you can do that by entering in DT and passing it the data structure you want to look for. So in this case it's going to be eProcess. And here we have things like create time. So knowing when, you know, malware started up in memory might be helpful, especially if it's in like C, Windows, System 32. If that did not start with, you know, a lot of the other ones that legitimately would have started at that time, that's going to be a process you want to take a look into.
You're running this on a live system?
No. So what I have here is I'm running it against this memory dump right here. Okay, and I infected this box with poison ivy and ran Moonsoul's Win32DD, and now I'll go through and just dump all RAM. Great program to use. So we're going to go ahead and take a look at, if we call self.eproc, that will actually, self meaning the current context the current process that we're taking a look at, and it will fill in all those values of the eProcess data structure with that specific process's data. So here we see that the create time was 2012-09-27. So then we start getting into, since we're talking about malfind, we're going to talk about the virtual address descriptor, which is called the VAD. All right. What the VAD is it's the memory of a process that's actually being used. When a programmer goes and says, for this program, I need, X amount of memory. Windows does not immediately allocate that memory. It waits until the program actually references that memory and then creates it. So each process will have its own VAD, and the VAD looks like a tree structure if you hang a tree upside down. So you have your VAD root, and then it just branches out into a list, and you'll see that here. So there's two different types of data structures that that are related to the VAD. We're going to take a look at the MMVAD short, and you see that it will have a number of different members in it. Tag being one of them. Tag describes what kind of VAD it is. This being VAD-S is a VAD short. All right, and the structure I'm talking about, the tree structure, is defined right here. You see left child and right child. That is referencing, it's a pointer to another area in memory that contains another VAD. So because this gets really long, we just end up putting VAD root. We called VAD root in the previous line. This one we're going to assign it into a variable and just work with it from there. So we're going to call this processes, we're going to call the processes VAD roots right child. And nothing special here except, you see the data values change. This is how you navigate the VAD tree system, all right, for a process. And you see, I'm not going to do these because last time it didn't really help that much, but just seeing the commands itself, you see that you can keep navigating by doing right child, so it'll be that right child's right child, and you can go left child, right child, but that's how you meander through. So when we looked at the data structure for that VAD system, you see this U. So we can go ahead and call that U. And right now, you see that long VAD and VAD flags belong to U. And what ends up happening is malfind will go through looking at the VAD flags. It will look at the type, like the tag, and it will look at any kind of memory protections that are on those memory pages. And the VAD is describing those memory pages. It'll go traverse the VAD tree for each process, or the process that you give it, and look for the protection level of 6. Now, the protection level of 6 is specifically interesting because when doing process injection, like Poison Ivy does, or you can configure Poison Ivy to, it will end up creating, wow, this is bad. All right, you'll get this page execute read write, which here you see 04, and there's another residual, like, just characteristic of virtual alloc EX, where it'll add 2 more to that constant. So it ends up becoming very unique in that you have this read write execute of this page in memory. So when you do process injection, you have to throw your code up into a process's memory space, and it has to be executable for the process to actually run. So virtual alloc EX leaves this characteristic of the protection of that memory page being 6. So Malfine will go through and look for any protection levels of 6, which gives you that page execute read write. Right. The other interesting thing is that virtual alloc EX is usually of VAD S, which is just the short one that we were specifically looking at. So, any questions over Malfine? All right, I know that was a lot, but there's one last thing I'll show you with Malfine, and that you can run a very simple bash loop to go through, because Malfine will dump out those pages in memory into a directory that you give it, and it'll have all these dumps. If we go in there and just do a loop over all the files that are in there, you can see what kind of file it is. If it has, if it's an executable file, it should say, it's a Windows executable file. Then you can go in and inspect that page. And see, is there the beginning of the MS-DOS stub if it's in there, or even if this is executable code. And the last thing I'm going to show you today, which is really cool, Volatility is doing this month of volatility plugins, where they're trying to launch a plugin every day. The coolest one, I still have time to, or still need some time to go through a lot of those plugins, but the coolest one I've seen so far is, it's called Sessions, and it goes through and tries to map up processes to the RDP session that it belongs to. And you'll see here that I have, whoops, wrong one. You'll see here that I have 2 sessions that have been created on this box. Up here, you have session 0, as defined right there, because it says ID 0. You see all the processes that belong to it. And then down here, you see sessions 2 and 3. And because this is just a regular Windows XP box, I believe that's why you'll see I actually RDP'd into this box, and I issued a couple of commands on the command line. Now, because it's a regular Windows XP box, you'll see that the command.exe is under session 0, which is that console session, as if you're actually in front of the box typing those commands in. And session 3 here was the actual RDP session. One last thing of note is that this VMX FBDLL is an artifact that just shows you that this is going to be a virtual machine. And that's basically it. So Any questions?
How good is volatility's documentation? I mean, have you been using it as a source for learning, using the volatility's own documentation or another source?
All right, the question is what's the quality of volatility's documentation? If you're looking at it specifically for like incident response, no. Their blog is great. Each of the people that actually do, the contributors and the authors of the tools do great blog posts too. I think it's the Malware Analyst Cookbook touches on, how to use it for incident response. So that's the way that I've learned, and through a little trial and error and a lot of reading. The developers' documentation is fantastic. So, any other questions?
Cunningham, will you be posting a guide on your blog?
A guide on how to use volatility?
Yes.
I do go through and talk about it every once in a while, but no, there will be no comprehensive guide. Is that it?
One question.
Yeah.
Brett. So, out of all the memory analysis tools you use, you like volatility over HB Gary's Responder Pro?
So
I know this is kind of
yeah, the question is, there's different memory analysis tools out there, and why do I like volatility? I haven't really played with Responder Pro much, to be honest. That's one that he specifically asked about. It's I don't know, it's a lot of money from my understanding. Volatility's been working for me so far.
Volatility is free. Responder costs money.
Yeah, I mean, that's a great point. Volatility is free. So I was able just to download it and play around with it, and I haven't hit something that I want to do in volatility that I can't do or that they're not working on. So I haven't had the need to pay a lot of money for something I can do for free. So, any other questions? All right, thank you guys very much for attending.
We tested